Hi everyone, today I have a special repair project on my hand. I'm going to be fixing up my friend's laptop and give it a deep clean and replace thermal paste, pretty standard stuff. I will also add a new SSD and give it another RAM stick. I will also be swapping out both 12 volts and CMOS batteries. But what makes this repair particularly interesting is a sneaky design flaw that can render this laptop completely unbootable, especially if you're not into electronic repairs or quick enough to catch those blink and you miss it blue screens. Alright, here is the patient. This laptop has been through a lot. It's probably its first service in the past decade. Before we jump into disassembly, let me explain what happened. Well, the default BIOS settings on this model are actually not compatible with the installed system. Basically, if both 12 volt and CMOS battery dies, then BIOS resets to its defaults and bam, it won't boot up anymore. It's like a built-in time bomb. Let's get to work. First thing first, I'm going to take this thing apart. With the cooling system out, it's clear this laptop needed a good cleaning. A brush and some IPA will be super helpful here. Now onto the thermal paste. The old paste has dried up, which can really affect cooling performance. I'm cleaning it off and applying some PTM 7950 to keep the CPU running cool. Next up, it's BIOS battery time. The CMOS battery is particularly important here because it keeps the BIOS settings alive. Without it, if the laptop loses all power, those pesky default settings kick in again. With everything cleaned and reassembled, it's the moment of truth. I will power it on and we have lift off. But just powering on isn't enough. If the BIOS reverted to RAID mode and the OS was installed in AHCI mode, Windows will blue screen or fail to detect the storage controller entirely. Inside the BIOS, under the SATA operation tab, you can see that the RAID on is selected. That's the default configuration, but it doesn't play nicely with an OS image from Microsoft Windows installation software, in which the RAID driver, typically Intel's RST, is disabled by default. So, when the BIOS suddenly switches to the RAID, Windows no longer knows how to talk to the hard drive. You can imagine that's quite an obstacle. The system is trying to boot over a storage interface for which no driver is available. The solution is either to switch the BIOS setting back to AHCI, or if you actually want RAID, to manually enable the RAID driver in Windows before changing the BIOS. That way the OS won't crash on boot. Here I'm checking if both RAM sticks are properly detected by the operating system. Temperatures also look good, nothing to worry about here. Now let's take a look at the performance of the new SSD. The old hard drive managed around 118 MB per second for sequential read and write, and a worryingly low 1.5 MB for random read. The new SSD, as expected, performs much better. Sequential read-write speeds are over 500 MB and random read is close to 360 MB per second, just as the manufacturer claimed. So there you have it, a solid repair, a fresh thermal compound and a small but meaningful hardware upgrade. If you find this video helpful or interesting, don't forget to subscribe and give it a like for more tech tips and fixes. Thanks for watching. Bye.